Alright, in this video we're going to look at more Lewis electron dot structures, covalent compounds, with a little bit more complicated structure. And so this is where we're going to bring in this last step that we didn't really do in the last video. So we looked at these first three steps. Again, you get the basic layout, and then you add up the valence electrons to figure out your total, and so forth. But what we didn't look at was this last step, because we didn't have to do that in any of those systems. If necessary, shift unshared electrons to make double or triple bonds to complete octets for these four elements, for carbon, oxygen, nitrogen, or sulfur. Those are the main ones that will do double or triple bonds. Most other elements just can only form single bonds, although they might make more than one single bond for that. All right, so that's what we want to take a look at here. So let's take a look, first of all, at CBr2O. With two bromines and one oxygen. So as before, we need to figure out what the central atom is going to be. It's the least electronegative. It's usually the first one listed in the formula, and in this case that's going to be the carbon. All three of these other ones are going to be attached to that. So let's draw our carbon in here, and I'm going to have the oxygen sticking straight up. One bromine out this way and one bromine out this way. One of the things we had said is that, again, when we're looking at the molecule layout, again, it's usually symmetrical around that. So again, I just kind of centered everything around that carbon or the carbon-oxygen bond for that. So that's our basic layout for this. And so the next thing we're going to do is add up the valence electrons. I'll bring this in over here. So we need to add up our valence electrons. So we've got carbon, we have two bromine atoms, and one oxygen. And so for this, we'll look at the periodic table here. Carbon's going to have 4 that it starts off with. And then we have two bromine atoms. It's in the same column as fluorine and chlorine, so each one has 7. So that'll be 2 times 7 for the two bromine atoms. And then the one oxygen is going to have 6 valence electrons. So there's our 6 for that. And so we just want to add those together. So we've got 14 here, plus 4, plus 6. That's what, 10, and 14 is 24 valence electrons then to work with in this. So the next thing we're going to do, we've already done this step essentially when we drew our structure here. We've attached the two bromines and the oxygen all to the carbon atom. That uses up 6 of the 24 electrons. So we've got 18 18 more that we can put into this. So the next thing, we're going to add in the remaining electrons. Those go in on those terminal atoms first. So again, if you need to, you can go back and look at the other video just to review this. That's why I'm going through this kind of quickly. So this bromine already has 2 electrons. It needs 6 more to complete that octet of electrons. So we'll put in 2, 4, 6 more to go with the 2 in the bond there, that straight line. Again, there's 2 electrons there. So that's 8 total there. Let's do the same thing for the oxygen. And that'll complete the octet there. And then let's complete the octet down here for the bromine. All right, so that finishes off all of the octets for all the terminal atoms. And so again, when you finish a step, just go back and check and see how many electrons you've used up. So there's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 electrons. And that's how many we had to start with. But we're not done yet. Why aren't we done? That's right, the carbon atom here only has 6 electrons, 2, 4, 6 electrons there, and so it doesn't have its octet. All right, and so why can't I just put 2 dots on there? Well, I can't just put 2 dots there because that would then put 26 total electrons in there. I've only got 24 to work with. I can't use any more than that, and no less than that. So I can't just put 2 more dots in there. So this is where this last rule comes into play. It says, if necessary, shift unshared electrons. The unshared electrons, that's any of these on the bromine or any of the ones on the oxygen there, shift those unshared electrons to make either double or triple bonds. You do this as you need to complete the octets for these elements, for carbon, oxygen, nitrogen, sulfur. So if you just remember, those 4 elements are the ones that you're typically allowed to make double bonds between. That'll make this a lot easier then, because that really narrows down our choice then for where we're going to make that double bond. So what we want to do is we're only going to do this between the carbon and oxygen, because it can only be between these elements in CONS. If you just remember cons, that's a quick way to remember which elements you're allowed to make double bonds or triple bonds between. So what we're going to do then is move a pair of electrons off of the oxygen and make those a bonding pair of electrons. So we're going to move it and put a second bond between the carbon and the oxygen, just moving one of the pairs of electrons off of there. So that pair of electrons still counts towards the oxygen because it's shared between the carbon and oxygen, but now it also counts towards the carbon. So let's go ahead and draw that structure down here. Here's my two bromines that I had before, and I'll complete the octets on those just like I had before. But now, instead of one bond to the oxygen, I'm going to have two. Again, when I move that lone pair of electrons, that's going to give me two there, and I'll just leave my other two pairs in the same spots they were before. So I've just moved that one pair down here and made that double bond between the carbon and the oxygen. And so I still have 24 electrons in here, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 electrons. But now I've satisfied all the octets, including the carbon atom. It's got 2, 4, 6, 8. Again, each line is 2 electrons. So 8 there, 8 around the oxygen, 8 around each bromine, and that completes all the octets that we need. All right, let's try a different system here. Let's try HCN. And in this case, again, remember we said hydrogen can never be the central atom, and that's true here. In this case, the chemical formula pretty much tells us what the layout of this molecule is going to be. It's going to be a hydrogen attached to a carbon attached to a nitrogen for this. And so let's figure out how many electrons we have to work with. There's one hydrogen, there's one carbon, there's one nitrogen. And if we bring in the periodic table here, hydrogen can have one valence electron, so 1 for that. Carbon's going to have 4. And nitrogen is going to have 5 valence electrons. So if we add that all up, that means we have 10 total valence electrons that we have to put into this structure. We've already used 4, 2 here and 2 there, and hydrogen's done. Remember, 1 and done for hydrogen. That's all you ever need to do for hydrogen is just put one atom attached to that. So the next thing we're going to do is complete the octet on the other terminal atom, again, because the hydrogen was all set. So we'll complete the octet on this nitrogen. It had 2 electrons, and so I needed to add 6 more to that. So there's 2, 4, 6 more electrons to that. That gives me 8 electrons around the nitrogen. All right, again, let's double check to see how many electrons we've used total now. 2, 4, 6, 8, 10. That was all 10 electrons that we had to put into this structure. But we're not done yet. Why aren't we done? Because the carbon atom there only has 2, 4 electrons, 2 here and 2 there. So it's only got 4 valence electrons. It needs 4 more. Again, it wants that octet of electrons. So to do that, what we're going to do is like we did here with this oxygen. And again, we're allowed to do this. This is this last step that we're looking at. If necessary, shift unshared electrons. Cons, carbon and nitrogen, you can do this between. And so I'm going to move one pair of electrons from the nitrogen in, make a double bond in there. If we just do that, that's what we end up with there. We still have the octet on the nitrogen there. Now we're up to 2, 4, 6 electrons on the carbon. Not quite there yet, but it's getting better. So we're going to move one more pair of electrons off of the nitrogen and make another bond in between the two. This makes a triple bond between the carbon and the nitrogen. Leaves that lone pair there. So we've got 8 electrons around the nitrogen, 2, 4, 6, and then the 2 there make 8 for the nitrogen, 2, 4, 6, and then 2 more here to the hydrogen, make 8 around there. Again, covalent means they're sharing those electrons. So the electrons in those bonds count towards both of the atoms in that bond. So the 6 electrons here count both towards the carbon and the nitrogen's total. And the 2 electrons here count towards the carbon and the hydrogen totals there. All right, so we end up with a triple bond between the carbon and the nitrogen. All right, let's try this last one here. Let's try carbon dioxide, CO2. And so again, carbon's going to be the central atom. There's only one carbon atom there, so we'll have an oxygen going this way, oxygen going that way. We make the molecule as symmetrical as we can. And let's figure out our electron totals here. And so carbon's going to have 4 from that. And there's 2 oxygens. So 2 times 6 for that. That's 12 there, plus another 4. What is that? 12 and 4 is 16 electrons that we have to put into this. All right, so next step, that's our total number of electrons. We've got to use all 16 in this. We've already used 4. Let's complete the octets on those terminal atoms. So 1, 2, 3, 4, 5, 6, because there was already 2 there, so I need 6 more on that terminal atom there. 2, 4, 6, 8 now around that oxygen. We got to do the same thing to this oxygen over here. So 1, 2, 3, 4, 5, 6 more there. That completes the octet there. You see what happens? We've got 8 electrons now, 2, 4, 6, 8 there, 2, 4, 6, 8 there. That's all 16 of our electrons, but the carbon's not happy yet. It's only got 4 electrons, 2 here and 2 there, and so we need to make some double bonds here. Again, it's carbon and oxygen. We are allowed to do that, and so we can take a pair of electrons here and move them in and make them bonding with that. And so let's just go ahead and write that up here. So I got a double bond there, got my electrons left there and there, and if I still have the single bond on this side, all right, not complete yet though. We've only got 6 around the carbon. All right, and now I could make a triple bond here, or I can make a double bond on this side. Remember symmetry. We typically want everything symmetrical as much as possible. And so I'm just going to do the same thing then. Let's take a pair of electrons off of the oxygen, move that in, and make another double bond on this side of the carbon. And so when we do that, let me draw that one down here. So there's my double bond between the oxygen and carbon there. There's the one I had left before. And there's all my remaining electrons. And now we've got 8 electrons around the carbon, 2, 4, 6, 8 there, 2, 4, 6, 8 around this oxygen, and with the 2 double bonds to the carbon, 2, 4, 6, 8 electrons there. That's the Lewis electron dot structure for that system there. All right, so it ends up with 2 double bonds to each carbon. All right, so those are just a little bit tougher molecules.